Okay, so now I want to talk about the practical part of the lab itself. So remember that what we just talked about in the previous video is that you're going to try to get the enthalpy of combustion of a metal. Now, in this particular lab, we have a couple of different choices of metal. It's going to be either zinc or magnesium. We used to use calcium and aluminum, but they no longer work as well as they should. So we're just going to focus on these two metals. Okay. So you have a couple of delta H that you have to measure, right, experimentally. It's going to be the metal plus HCl and then the metal oxide plus HCl. So for example, if you're using zinc, then it's going to be zinc plus HCl. The oxide will be zinc oxide plus HCl. Measure those two things, and then you're pretty much done with the lab. Okay, it's important to understand that each of these has to be measured twice, so we get at least repeat data in order to get more precise average. So that, in other words, in total, you're going to have 4 measurements of delta H, 2 of each of these to take an average of. Here's what these containers look like for the zinc and the zinc oxide, and then for the magnesium and the magnesium oxide right here. One thing to be careful of is that these uh, substances are going to be placed inside the fume hood. The reason is because a couple of reasons. The zinc itself actually comes in the powder form, and sometimes you don't want it to accidentally get breathed in while you're working on it outside, so we usually just put it in the fume hood for safety. Same reason for the powder of the zinc oxide and the magnesium oxide. Those are even finer powder, and we just want to make sure that everybody's safe. So all of those guys are just going to be placed in the fume hood. You're going to have to make the measurement inside the fume hood. A little bit of an issue, practical issue here that we have to talk about with making measurement inside the fume hood. When you put the balance inside the fume hood, remember that this balance works by corresponding pressure changes with mass. Okay, now in other words, that plate that measures mass is actually measuring pressure changes. Now, if you have a room where there's a lot of pressure changes in the gas, in the air, for example, that's going to make this balance values jump up and down quite a bit because of the pressure changes in air. A fume hood actually is something like that. A fume hood, remember that the function of this is to remove air. So there's a fan on the top of the fume hood, right, that sucks air, and as a result you had flow of air continuously through the fume hood when the fume hood is working. Now, that means that if I put this balance inside the fume hood, I'm going to see fluctuation in the numbers of mass that I measure, and therefore it's hard for me to get an actual mass for the coffee cup or for the coffee cup with the HCl once I put it in. So what you have to do is the following. We're going to put a little shield around the balance. Okay, this little cylinder, glass cylinder, that would basically block out the air. And then in addition, make sure you put a cover on top of it to make sure that the air is not fluctuating and changing the mass inside. The more you enclose this whole compartment here, the better and the more precise the mass measurement is going to be. Here's an example of what the good measurement looks like. You notice that I cover the whole sides with these glass cylinder shields, and then on the top I put that cover with on top of that even a cover that covers that little hole that's usually on the top. Okay, so that completely isolate or insulate the balance from pressure changes that is a result of the fan that's blowing on the fume hood. Another thing to pay attention to, there's 2 different HCl that's going to be provided in the lab. One says 6 molar, the other one says 1 molar. Make sure you look carefully into your lab procedure to know which one you're supposed to use with your metal and metal oxide, because not everyone is going to use 6 molar and not everyone is going to use 1 molar. Now let's talk about the setup here. You're going to pick one of these coffee cups, right? There's 2 of them set up together. You're going to basically pour your HCl in there, and then you're going to put your metal in there. As soon as you have both of those things in there, you're going to have a thermometer inserted into one of the holes in the lid of the styrofoam cup. And then in the lab you should see these test tubes that have a bunch of stirring rods in them. The only thing you need is not this test tube, but just the stirring rod. So take the stirring rod out and insert the stirring rod in there. the bottom part of the stirring rod has been shaped to allow you to mix the substances inside here, inside the styrofoam cup. So this is what it looks like once you set it up. You can put the cup inside a beaker. That would stabilize the cup so it doesn't accidentally fall out. If it falls out, you know, your reaction is gone and spilled, then you have to repeat that experiment again. So please do that during the lab itself. Quick reminder, you're going to let that experiment go, noting the initial temperature and then noting what the final temperature is going to be. Okay, it might go up, might go down. Whatever that final temperature is, you subtract the final minus the initial, that's your delta T, right? Multiplied with the specific heat of the solution and the mass of the whole mixture that's in there, that's your delta H of the surroundings. Remember now, and then to get the delta H of the system, which is the reaction itself, you have to take the negative of this number. Very important. Don't forget to mix. The whole point of having that stirring rod is you got to move it up and down to mix the solution inside. If you just pour things in and just look, nothing's going to happen. The reaction, the thermometer is going to measure reaction that happens near the thermometer, but there's some other parts of the reaction might not be happening, and then you don't know. So unless you mix, the whole mixture, the whole reaction is not going to be uniform. Okay? Now, of course, you're going to know when the reaction is over when the temperature doesn't change anymore. All right?